How to reduce construction cost of a building. The technical content in this session is already familiar to the experienced engineers. However, it is intended to provide basic useful information to the general public and to serve as a guidance for fresh practicing engineers. The information presented here is only a general guideline. Owners are advised to consult their engineers before adopting it for their specific requirements. Let us explore some fundamental concepts related to buildings. Buildings are mainly classified based on their usage as follows. Residential, that is single house, row houses, duplexes, group houses, flats, quarters, etc. Commercial, educational buildings, healthcare facilities, malls, bazaars, corporate offices, etc. Industrial, buildings related to industries. They are usually steel or RCC framed structures. Public buildings, all types of government and institutional buildings. To reduce the cost of construction, the following aspects are essential. Economic planning, economic design, economic construction, that is use of innovative materials and methods. Low cost construction involves use of low cost or cost effective materials which can reduce the construction cost. Economy in planning. What should be observed during planning of a building? A proper decision should be made regarding the adoption of a framed structure with columns and beams or a load-bearing structure without columns and beams. Load-bearing structures are suitable for residential buildings up to G plus 2 floors where the founding strata consists of very hard soil, ordinary rock or hard rock provided proper design criteria are followed. Land survey. Conduct a land survey to plan the layout according to the natural profile of the ground, thereby avoiding unnecessary excavation or filling. Soil investigation, that is exploration. Test the soil for its safe bearing capacity through a reputed consultant or engineering institution. This step is extremely important for ensuring both safety and economy in construction. Grouping of rooms. Group different rooms such as veranda, hall, dining room, kitchen, bedroom and toilet, that is water closet, in such a way that cross movement is avoided. Avoid placing doors diagonally in the hall or dining area as it divides the usable floor space and affects the functional layout. The following sketches show the incorrect and correct grouping in general. The first one, which is not correct, that is, you can see there the doors in portico and in hall, they are provided diagonally, and even in kitchen. The arrow mark shows the movement of the occupants, which divides the veranda as well as hall. So floor area will be less useful if you provide the doors in this way. And in the second one, you can see the doors are provided in the same direction so that the hall veranda floor area is not divided and will be used in a better way. Providing headrooms. Generally, the minimum headroom for residential buildings is 3.05 meter, that is 10 feet clear. Clear means from the top of the floor up to the bottom of the slab, that is ceiling. However, this may vary depending on individual preferences and architectural design. A simple sketch to know the different parts of a building is shown below. Let us start from the bed concrete, then foundation, that is UCR. This is shown for load bearing structure. There is a ground level. Above that plinth, the right side we have shown the steps. Then plinth beam might have been provided. DPS means damp proof course to avoid capillary action, that is dampness in the wall. PCC or RCC sill, that is plain cement concrete or reinforced cement concrete for sill. Generally it will be PCC. Sometimes we may provide RCC in case of buildings constructed on loose soil. The portico portion, door, window, left side fins, then chajja, brick wall, finished floor level, then headroom, as I have seen, explained already, that's from the top of the floor up to the bottom of the slab, which is called as ceiling. Then the RCC fascia, RCP drop, canopy over portico, RCC plain slab, and parapet. Plain slab means it is flat. Otherwise, there in some buildings we may go for sloped slabs also. Fixing the plinth height. The plinth height may be kept around 0.6 meter, that is 2 feet, above the top of the center of the front asphalted road, and 1 meter to 1.15 meter, 3 to 3.5 feet for plots facing mud or gravel roads. It also depends on the natural ground profile of the site. If the front road is sloping, the plinth height shall be fixed from the upper corner if the ground is not leveled. That has been shown here. You can see here in the right picture, the natural ground is sloping and the plinth is provided 60 centimeter, that is 0.2 meter above the center of the road. Similarly, that has been shown in the other drawing also. Room dimensions. The dimensions of the rooms depend upon the plot size and their specific utility and comfort. However, the general minimum room sizes based on functional requirements standards are given below. Veranda, you should have minimum 2 meter by 3.05 meter, that is 6 feet by 10 feet. Hall 3.05 meter by 5 meter. Bedroom 3.05 meter by 3.65 meter. Master bedroom 3.65 meter by 5 meter. Bathroom 1.2 meter by 1.5 meter. Water closet 0.9 by 1.2 meter. Note, the above sizes are minimum sizes required from utility point of view. However, these sizes may vary according to the space availability and the owner's requirement. The owner and the engineer or architect shall decide the sizes as per their requirement and taste. Planning according to ground profile. If the ground profile is uneven or sloping, utilize the natural contours to achieve an attractive plan and elevation. Avoid excessive excavation or filling by unnecessary cutting and leveling of the ground. The sloping ground can be utilized as a cellar for a housing unit or garage, etc. You can see in the sketch the ground is sloping from the front side to the rear side. So you can have this sloping space to construct a building for residential, or you can have a garage. So excavation is minimized and filling is not there. Only except the front side filling is shown, like how you have to have economic excavation and filling. Fixing the sizes of doors, windows and ventilators. This includes determining the sizes of door, window and ventilator openings. However, the size of the frame and the thickness of shutters also contribute significantly to the overall cost. For economy, provide 2.5 inch by 3 inch frames, except for the main door. The thickness of frames of shutters may be kept between 1.5 inch, that is 40 mm. The thickness of the shutters panels may be kept as 1 inch to 1.5 inch. Generally, adopted frame sizes are 3 inch by 2 inch, 4 inch by 3 inch, 5 inch by 4 inch, and occasionally 6 inch by 6 inch, generally for main door. Reducing the sectional size can help in cost saving, though it ultimately depends on the taste and choice of the owner, engineer and architect. Different types of carvings or designs can also be adopted as per aesthetic preference. Sizes of door windows frames are shown below. They are 2.5 inch by 3 inch, 3 inch by 4 inch, 4 inch by 5 inch, 6 inch by 6 inch. Providing ornamental elements. As far as possible, avoid excessive ornamental features such as curves, offsets and slopes that do not serve any functional purpose. Although too many architectural elements may enhance the appearance of a building initially, they often become difficult to maintain over time and may eventually look unattractive. An example of a simple and aesthetically pleasing building is shown below. However, this depends upon the taste and choice of engineer, architect and the owner. Deciding the materials to be used. For the same building items, a wide variety of materials with different qualities are available in the market. Though the selection depends on the owner's choice and preference, the economic aspect should also be considered. Keep in mind that the latest materials available today may become outdated within a year or two due to rapid technological advancements. Today's advanced design may become outdated within a span of 5 years or so. In many cases, the buildings built by parents may not be liked by their children during their lifetime due to latest design of their generation. So it depends upon the owner to choose the materials intellectually. Different makes, brands and company products are available for various categories such as electrical items. In this, PVC pipes, electric wires, cables, switches, switchboards, meter boards, fans, bulbs, decorative lighting bulbs, etc. Plumbing pipes by pressure rating, that is PVC pipes of 2 kg per centimeter square, 4 kg per centimeter square, 6 kg per centimeter square, 8 kg per centimeter square, etc. are available in the market. By material type, PVC, polyvinyl chloride, CPVC, chlorinated PVC, UPVC, unplasticized PVC, and PVCO, that is molecularly oriented PVC. The photos of the pipes are displayed in the next slide for your reference. CPVC and UPVC, they are shown here. These are all CPVC and UPVC pipes which are available in the market, which are of good quality and long during pipes. The type and class of PVC pipes shall be determined by the engineer in charge based on the intended use. Lower pressure PVC pipes are generally less durable than higher pressure ones. For critical applications where water pressure is relatively high, such as municipal water supply, gas distribution and drainage, HDPE, that is high density polyethylene pipe and LDPE low density polyethylene pipes are used depending on the specific requirements. Stoneware pipes are typically employed for underground drainage lines as they are resistant to chemical reactions caused by the contact with sludge. However, in recent years, high pressure PVC pipes are also being used for underground drainage, that is usually lines, pipelines. The following pictures show the stoneware pipes of different types. Paints. Paints are also available in different brands with different types. Some types of paints are listed below. Oil paint, enamel paint, emulsion paint, bituminous paint, cement paint, that is distemper oil bond and waterborne paint, anti-corrosive paint, synthetic rubber paint, aluminum paint and other specific paints for factories and telecobalt therapy treatments rooms. Non-radiation paints are also available. Different finishes of paints. Gloss finish or glossy finish, that is very smooth like glass surface. Matte finish, that is non-glossy or non-reflective finish. Textured finish, texturing in painting for aesthetic look. Satin finish, eggshell finish, artistic finish, that is art in painting. These are the type of finishes of paints. Emulsion and other glossy finish paints surfaces are washable, but they are more expensive than other types of paints. There are also waterproof paints available in the market such as epoxy paints, oil-based paints and acrylic paint. Each of these is used for specific purpose and their durability and water resistance vary accordingly. Economy in construction from importance of the building point of view. It is not advisable to spend excessively on buildings of lesser importance such as temporary structures, godowns, minor structures, warehouses or structures at remote locations. Mode and methodology of construction. Use manpower for small scale works and machinery for larger projects. Advanced technology. RMC, that is ready mix concrete, prefabrication and PSA, that is pre-stressed concrete, may increase the initial cost but save in time. So, because time is the cost, which indirectly reduces overall cost. They also ensure better quality concrete provided the supplier is reliable. You can see the transit mixer and the RCC which is being done with ready mix concrete. Remember, the pouring of concrete height should not be more than 1.5 meter, that is 5 feet as per IS 456 code. Life of the structure. As mentioned earlier, if a structure is intended for a temporary period, excessive expenditure should be avoided. Budget provision. The budget plays a crucial role in determining the cost of a building. Planning without considering the budget can lead to extravagance during construction. It is very important to note that many people do not consider the maintenance cost required during the life of the structure while preparing the estimate. So you should consider the maintenance cost also in the estimate to have economy in the future of the building. There must be provision for maintenance also. This is very important for government projects. You might have observed many of the government buildings, they are not properly maintained because of paucity of funds, which was not considered at the time of preparing the estimate for that building and proper budget provision to maintain. That is why such buildings are deteriorating day by day, which is a national waste. Climatic conditions. Severe climatic conditions can increase construction costs due to the need for sloped slabs, thicker structural elements, waterproofing, and other protective measures. Escalation in market rates. This depends on the demand and supply situation in the market. Market fluctuations are inevitable. Artificial shortages are unexpected situations such as COVID-19 may also increase costs. Therefore, potential escalation in market rates should be considered by including an additional budget provision in the estimate itself. Natural and man-made disasters. Events like floods, famines, wars, bomb blasts, and fire hazards are unpredictable. However, if they occur, they can lead to additional expenses. Time is money. Delay in building project execution results in extra expenditure due to escalation in material and labor cost. That is why time plays a vital role in the total expenditure of the building to be constructed. Bonus option. In government projects, providing a provision to award a bonus to the executing agency for completing the work well within the stipulated or scheduled period may also help to reduce overall project cost, because the agency will speed up the work in order to achieve the bonus, which will be a cost saving indirectly. Adopt the actual soil bearing capacity based on the soil test report instead of relying on simple assumptions. Consider the appropriate loads and forces as required in accordance with the IS code provisions. Determine the minimum sections of structural elements based on the design criteria. Design the structure in accordance with the ground profile to have economy. Consider seismic forces only when the necessary as per IS code. Select the appropriate grade of concrete and steel depending on the structure and its intended use. These should be followed at the stage of designing. Litigations and legal obligations, very important. In many cases, a lack of understanding of legal aspects such as obtaining consent from the owner of an adjoining site for clarifications regarding the site dimensions, awareness of ongoing court cases or issues of ownership among legal heirs can lead to work being stopped midway. Such delays inevitably increase cost of construction due to escalation in market rates and labor wages. Litigation in residential building execution. A common issue in residential building projects is encroachment on boundary lines. Always measure the dimensions of adjacent plots starting from the edge of the road. If the owner of the first plot from the road edge makes a mistake and subsequent plot owners continue with the same error, it will result in incorrect dimensions for the following or successive plots, potentially leading to litigation. This delay causes additional cost of construction. To avoid this mistake in measuring the plot dimensions, an example is explained in the next to this. How to measure your site dimensions? Refer your site plan. Observe the dimensions. For examples, look at the layout shown below. If your plot number is 26, measure dimensions of plots 23, 24, 25 from point I, or plot 30, 29, 28, 27 from point J. Then confirm the width of your plot. Similarly, confirm the depth of the same plot either from point C or from point D upwards, or from point I or point J downwards. A to L are references points to take measurements. Incompetent executing authorities. If the executing or supervising engineer or agency lacks sound technical knowledge and experience, it increases the cost of the building. The longer it takes to make proper decisions, the higher will be the cost. Many owners place more trust in masons than in engineers due to the masons' false promises for constructing the building economically without an engineer. However, owners often remain unaware of hidden costs in the masons' rates and their lack of technical skill, which can lead to greater expenditure to resolve technical defects in future. Most importantly, time is money. Delays directly increase cost of projects. In load-bearing structures, let us see the elements one by one. Foundation. Many people do not design foundations for load-bearing structures based on the actual soil-bearing capacity. Instead, the width and depth of foundation are often determined by thumb rule, which can lead to unnecessary extra costs. Even open foundations should be designed according to the actual SPC. Excavation. Manual excavation is more economical for very small scale works. For major or large scale structures, excavation using machines such as Hitachi or JCB proves to be more cost effective. Many engineers do not design foundations for load bearing structures based on the safe bearing capacity, that is SPC of soil. Instead, the width and depth of foundation are often determined by thumb rule, which can lead to unnecessary extra cost. Even open foundations should be designed according to the actual SPC. In case of hard strata with hard soil, ordinary rock or hard rock, the foundation excavation depth shall be minimum as per the design. The foundation below the openings is not required, but the plinth shall be provided as shown in the sketch below. The decision of the engineer in charge is final and it shall be final. See the sketch in which it is shown that opening in a building may be door or any opening inside the building, below which the foundation is not laid, but the plinth is laid throughout, whereas the foundation is provided on either side of the opening as shown in the figure. So this saving in foundation below the opening will reduce the cost of construction. As the load transfers above the opening to the foundation from the sides, the foundation below the opening is not required. However, the decision of the engineer is final. There are numerous cases where the foundation for a compound wall is constructed with the same dimensions as the main building's foundation, which is totally unnecessary. This issue can be addressed by providing smaller foundations for compound walls, which can reduce the cost. Precast compound wall elements have been proven to be more economical than conventional compound walls. In the case of black cotton soil, constructing compound walls on small piles also works out to be cost effective. Bed concrete. Concrete grades and mixed design. Let us see. Concrete grades include M5, M7.5, M10, 15, 20, 25, 30, 35, 40, etc. It goes up to M200. In terms of proportions, that is by weight, they are M5, 1510, M7.5, 148, 10, 136, 15, 124, 20, 1:1.5:3, 25, 1:1:2. In practice, volumetric proportion is being adopted while concreting manually. What do these grades mean? M5 means concrete giving a strength of 5 newtons per mm square after 28 days of curing. Similarly, M7.5 7.5 newtons per mm square. Likewise, M40, that is 40 newtons per mm square, is the crushing strength of the concrete after 28 days curing. As the grade increases, the crushing strength of the concrete also increases. Here, for example, 1:5:10 means 1 part of cement, 5 parts sand, that is fine aggregate, and 10 parts, that is jelly or metal or coarse aggregates. For grades above M25, the proportions depend on concrete mix design. For M20 and higher grades, a proper mix design is generally preferred as it ensures required strength and can save significant cost. Therefore, the owner should insist that the site engineer adopt concrete mix design and provide the specified concrete grade accordingly. Higher the grade concrete, higher the crushing strength, but also higher cost. Wet concrete, being a thin leveling course, does not require high strength concrete. However, it is common for people to provide unnecessary thick bed using high grade concrete, even in hard soils. Properly deciding the thickness and grade of bed concrete can result in substantial cost savings. Generally, for bed concrete, M5, that is 1:5:10, or M10, 1:4:8 is preferred depending upon nature of founding strata, which has to be decided by the engineer in charge. UCR masonry, that is uncoursed rubble stone masonry. In uncoursed rubble masonry, the stones are not dressed to inform size or shape. This type of masonry is typically used for the substructure, that is foundations below the ground level. Cement mortar of proportion 1:8, 1 part of cement, 8 parts of sand may be used instead of richer mix like 1:4, 1:6 to achieve economy. Plinth, that is CR masonry, that is coursed rubble stone masonry. In coursed rubble masonry, stones are roughly chiseled to a certain shape and size. This masonry is used for the plinth, that is the foundation above the ground level. If the plinth is constructed using size stone masonry, SSM, plastering is not required. The joints can be pointed using cement mortar 1:4, which is known as pointing. You can see CR masonry shown right side and a UCR masonry is shown on the left side. As an example, PCC over plinth, that is basement concrete. Plinth concrete without steel may be provided over the stone masonry plinth, typically using 1:2:4 mix. Using this proportion instead of richer concrete mix helps to save construction cost. Providing PCC over the plinth is not necessary if an RCC beam is already provided for the width of the plinth, which is called as plinth beam. You can see in the picture. RCC plinth beam. If the soil is very hard, providing an RCC plinth beam may not be necessary. However, if it is required, it should be designed properly and economically by the engineer in charge. You can see the plinth beam provided here. This plinth beam also helps in getting the rigidity of the building. In case of small earthquakes, the plinth beam will help to resist those earthquake vibrations. And also this plinth beam helps in reducing the slenderness of the columns. So the engineer has to decide the provision of plinth beam required or not. Wire cut burnt bricks. Sizes of different blocks. Burnt clay bricks. They are available in 8 inch by 4 inch by 4 inch, that is 200 mm by 100 mm by 100 mm, or 8 inch by 4 inch by 3 inch. Stabilized mud blocks, cement and clay mixed blocks, PCC blocks, 18 inch by 8 inch by 8 inch, 18 inch by 6 inch by 8 inch, 18 inch by 4 inch by 8 inch. They are available. (200 mm and 150 mm thick blocks available both in solid and hollow. Similarly, AACB, that is air entrained autoclave concrete blocks. also known as lightweight concrete blocks. They are available in 2 feet by 8 inch by 8 inch, 2 feet by 8 inch by 6 inch, 2 feet by 8 inch by 4 inch. Concrete pavers, two types, heavy duty and light duty. Heavy duty 80 mm thick and light duty are 50 mm thick. The utility of specific paver should be designed and confirmed by the engineer in charge. You can see the clay bricks and concrete blocks also. They are interlocking blocks shown in the fourth column, and clay bricks also shown, hollow and solid. They are cement stabilized mud blocks, that is, cement is added to an extent of 10 to 15% in the soil and the blocks are made. They are cured and they are also very good for construction of load bearing structures or partition walls. You can see pictures of AACB, autoclave air entrained concrete blocks. They are beautifully finished and give very good aesthetic. Plastering is not required, thereby saving will be to a greater extent. Paving tiles and solid and hollow concrete blocks. You might have seen in the market these blocks are also available. Different types of concrete pavers, beautiful design. You can have very good aesthetic view by providing such pavers for corridors, passages, etc. Sill, PCC or RCC. The sill is the leveling course provided below foundations and ventilators. Generally, in hard soils, it is constructed with PCC, that is plain cement concrete, with a thickness of about 3 to 4 inch. The sill may be cut sill. It can be provided only below the windows and ventilator, extending about 9 inches beyond each side for the bearing, and through sill. In case of loose soil, the sill may be provided along the entire length of the wall using either PCC or RCC for added strength and stability and also to avoid cracks. You can see the section of a wall. The plinth beam is there, PCC sill is provided, window is there. Above the window, the lintel is provided and it is provided with RCC Chaja. Doors, frames. The material for wood frames and shutters can be any suitable wood, like teak wood is available in different classes A, B, C, with class A being the superior quality. Teak wood is more expensive than other type of wood such as Nandi, Matti and Vani. Acacia is a less expensive alternative to teak wood, but its texture closely resembles teak. Because of this, it is sometimes sold in the market as teak to mislead buyers who are not knowledgeable about wood types. Besides, this Malaysian teak has also been used, although its use has declined in recent years. The size of the frames generally corresponds to the size of the window frames except for the front door. Door shutters. The shutters are specifically designed with carvings depending upon the choice of the engineer and architect and also the owner. Generally, the front door and puja door shutters are made with more aesthetic design and especially in teak wood. However, in the recent days, the puja doors are made of full size glass with etching according to the selected design and drawing. Advanced door shutters. They are flush doors. These are readily available in the market. These are doors work out to be cheaper and saves a lot of time in preparing the door and fixing in position. Other advantage of these doors is that they are available in multi-design and colors readily available. Generally, the puja door shutters will be with double shutters. Innovative door shutters are shown below. FRP, fiber reinforced panels. They are readily available with different size, design, make. Beautiful shutters are also available. ACP, aluminum composite panels are also available to fix them to the walls to have beautiful look. These are generally provided for public and commercial buildings. The maintenance will also be very easy in case if we provide ACP panels. Synthetic panels, they are also available. Synthetic doors are available in the market with different color, design, shape, size. Node boards, these are artificial wood boards which are also available in different thickness and different grades depending on the requirement. The owner and engineer can utilize them. Bison band, exterior grade and interior grade. Exterior grade bison bands are treated with chemical so that it can resist climatic effect of temperature, wind and other effects. Interior grades are not treated with chemical because they are within the building which are not affected by climatic effect. Windows. Windows may be of any size. Common window size is 5 feet by 4 feet. That is width is 5 feet, height is 4 feet. 3 feet by 4 feet. That is 0.9 meter width and 1.2 meter height. The height of the window is so fixed that it should touch the bottom of the lintel from the sill level. So generally lintel height will be 7 feet up to its bottom. So sill height will be 3 feet. Therefore generalized height of the window is 4 feet. But the width, height and shape of the windows differ from building to building depending upon the taste of the owner, engineer and architect. Windows are generally fully glazed, that is glass is provided for the shutters. Glass may be transparent or ground, that is partially transparent. The opening of the window should have minimum 10% floor area of the room to have sufficient light and ventilation. That is, area of that opening should be minimum 10% of the area of the floor that has to be provided. Some example of different shapes of window are given below. Rectangular, square window, bay window, slit window, small see-through window, round window, octagonal, hexagonal, pentagonal windows are also provided, or any other shape as decided by the architect or engineer or the owner. More the window openings, more will be the light and ventilation and less will be the power consumption and hence adds to economy, also to have good health of the occupants. Lintels. Lintels may be through or cut as designed by the engineer. They are small RCC beams provided over the openings like door, windows, ventilators or aesthetic openings. The section should be designed economically by the structural designer to achieve economy. Roof beams. These are RCC beams provided monolithic with RCC slab. These should also be designed for economic sections and actual steel required from design point of view to save money. You can see in the picture RCC lintel is shown, window, sills, plinth beam chajja as shown earlier. Roof. RCC slabs truss with asbestos sheets or zinc sheets. Decorative burnt clay tiles, precast PCC tiles of different design, shape and size are available to provide over the sloped slabs. Plastering. Clay and mud plastering. This is almost outdated except in rural areas. Lime plastering. It is a lime mortar, that is mixture of lime and sand mixed with water. It is also known as surki. The thickness of plastering is 12 mm and to 18 mm for inside surface of the masonry wall and 20 mm in two coats for outside surface of masonry. Cement mortar. This is present day common plastering over the brick or block masonry and over undulated concrete surface also. It is a mixture of sand and cement mixed with water in proportions like 1:1, 1:2, 1:3, 1:4, etc. Cement concrete readily available roof tiles are shown here. They are of different color, size, shape, design to have beautiful look. Flooring. Generally, the thickness of the tile is up to 12 mm. It is called as tile, and more than that it is called as slab. These are the varieties of flooring. Erguntla, that is rough shaba flooring, mosaic tile flooring, granite tiles, slab flooring, granite tiles or slab flooring, Adanga marble slab flooring, Betham Charla limestone tiles marble flooring, unpolished Kadapa tile flooring, polished Kadapa tiles flooring, Tandoor blue flooring, Kota tiles flooring, vitrified tiles flooring, quartz tiles flooring, wood flooring, polished Shabad tiles flooring, etc. Electrification. Concealed wiring. Wires will be run inside the wall by cutting grooves. Open wiring. Wires will be laid in PVC channels and fixed on the surface of the walls so they are open to access. Wires are available both copper and aluminum covered with plastic. Copper wires are costlier than aluminum wires. There are varieties of wires available in the market. You have to choose the proper wire depending upon the ampere and volts and whether required inside or outside. Electrical engineers decide the type of wire to be adopted for your home for safety and economy point of view. What is AH? An all electric home is with a 15 amp current rating category corresponding to a 3.5 kilowatt connected load and used for both heating, grinding, pumping, motors, geysers, microwave, etc., which are heavy duty devices. Water supply. For water supply arrangements, there are several types of pipes and fittings available in the market. Pipes may be PVC, UPVC, OPVC, GI, etc. In these days, GI, that is galvanized iron pipes, are almost not being used in practice except in special cases because of their high cost, rusting, and required more skilled manpower for cutting, threading, and fitting. Generally, good quality PVC pipes are being used as they have performed well since many years and proved to be cost effective. The other fittings like gate wall, bibcock, hot and cold mixer, shower, etc. can be chosen by the owner and the engineer or architect depending upon their budget. The photos of water supply fittings are shown at the end for reference. Some examples of water supply fittings are shown below. Pillar tap. Pillar tap, different types. Sink tap with extended swivel spout, wall mounted. Wall mixture provision for overhead shower. Different overhead showers. Snowball bibcock, continental brass chrome plated are available. Quarter turn fittings, two-way angle cock, quarter turn fittings, sink cock, which is wall mounted. Kitchen sink stainless steel sinks. Sink stainless steel, sink with drain board, double bowl stainless steel sink, bunker rod or napkin and towel ring stainless steel, granite kitchen sink, they are all available for kitchen sink. Steel fancy towel rod, washroom toilet paper holder, These are just examples. There are varieties of shapes and different materials are available in the market. Sanitary fittings. These are also available with several brands in market. They are PVC, HDPE, LDPE pipes, stoneware pipes, nani traps, gully trap, gratings, Indian water closet, Western water closet, and Anglo-Indian water closet, fixtures and fastings, urinal units, flush tanks, flushing units, air vents, cowls, etc. The photos of these are displayed at the end for reference. Painting. Paints are also available in different brands. It is difficult to say that which are the cost-effective paints, except that waterborne distempers are cheaper than oil-borne distemper. Sanitary fittings, you can see elbow, T-joint, end cap, collar, they are available. And you can see the commodes, varieties of commodes which are wall mounting and fixed to the floor, that is on the right top corner, which is shown. Availability of materials. Lead, that is horizontal distance for transportation. This is also very important for the cost of the building. Labor and their availability. Rural, urban, skilled, unskilled, men and women. In rural area, labors are available in cheap, but skilled labors are not available. They should be brought from the city. In city, the skilled labors are available, but whereas unskilled men should be brought from the villages. All these factors, they add to the cost of the building. Cost of higher charges of material machines to be deployed. For example, for excavation, Hitachi, JCB, bulldozer, for transportation, tractor, trucks, etc. will also add to the cost of the construction, which has to be intellectually decided by the engineer in charge. Structural component for framed structures. Footings: open, shallow, isolated, square, rectangular, combined rectangular, trapezoidal, raft or mat, trap, strip footings, etc. can be provided depending upon the need. Deep foundations: piles, cast in situ, precast, under-rimmed, RCC, steel piles, wood piles, sheet piles, group of piles may be provided for loose soils as decided by the designer. Column size, that is B and D, width and depth, should be economic. B shall be minimum 300 mm for seismic forces. Proper orientation of columns is very important from stability, safety and economy point of view. The structural design of the following elements shall be economic based on the minimum need, that is plinth beam or grade beam, lintel through or cut, roof beams should have economic sections, grid beams and slab, cantilever beams, slab, plain or sloped slab, flat slab with drop and without drop, precast concrete slabs, precast slab panels, etc. shall be decided by the engineer in charge. Filler slabs are proved to be economic, assessing loads and forces, which are also called as cost-effective slabs. Selection of grade of concrete and steel, which add to the cost of the cost, should also be cautiously decided by the engineer and the designer. Cost-effective planning includes proper soil investigation, proper planning, proper design, preparation of proper DPR, use of Primavera, Microsoft Office, critical path method, PERT for major works, detailed study of project before its commencement, use of proper tools and machines, use of precast elements, use of innovative materials, use of innovative methodology, quality and safety assessment provisions are necessary. Cost-effective innovative materials. AAC blocks, autoclaved aerated concrete blocks, soil stabilized mud blocks, that is fly ash blocks, cement concrete blocks, stone boulder blocks, gabions, filler slabs, FRP, ACP, synthetic panels, no wood, bison band wood, exterior and interior gate, UPVC windows, durable and less or no maintenance. This shall be studied. Bunches of stones known as gabions are required. These are required for major earth retaining structures. Cost effective filler slab, which are cost effective. They are known as low cost technology. You can see beautiful filler slabs available. That filler material is of less cost compared to the concrete, hence saves in construction cost. Laurie Baker, that is 2nd March 1917 to 1st April 2007. He was a British-born Indian architect renowned for his initiatives in cost-effective construction, which is known to many of the engineers all over the world. And many more based on the experience. Visit exhibition on building materials and get further more information to achieve economic and to have a beautiful building. More importantly, for petty works, work like labor for your own building to save money. Thank you.